Applications, the word that everyone hates, word problems. Actually using math to solve useful real world problems. Not all of the ones in math books are useful, because the sad reality is that actual application problems are really, really complicated and really messy. So it's hard to do actual applications in a classroom. So we do these fake little silly applications, unfortunately, but it's like a middle ground. Anyway, stop ranting, Jason. Start with the definition. Jason, you said start with the definition. Why are you drawing a weird picture? Well, let's look at this. All right. Say we have a situation like this. There's a building. There's a nice, it's a nice sunny day. Sun has a happy face, whatever. Say there's a picture. Then this angle right here is what's known as an angle of elevation. The angle from the bottom looking up at something, angle of elevation. It's the same as this angle up here, which is the angle of depression. That might be an angle that most of us are more familiar. Never mind. Angle of elevation, angle of depression. That's what those are referring to. Angle of elevation from the ground looking up. Angle of depression from the top looking down. And we're going to use those for some examples. So we're just going to do one example today. There's more in the book. Draw a lot of pictures. And here we go. To find, I'm not bothering to separate those words. It's one word now, kind of a conjunction. To find height of a tree, a person, you. Let's make this applicable. You walk 30 feet from the tree, from the base of the tree, and you measure an angle of elevation of 57 degrees. Pretty accurate. You can measure angle with your phone, maybe. There's cool measurement apps, or maybe you got out like a sextant or something. I barely know what those are. Every time I read it, I try to Google it again. I might be using the wrong word. Let me know. Between B/T for between the ground and the top of the tree. So this is what you're doing. And the question is, estimate the height of the tree. So whenever you have a bunch of words, an application problem, one of the best things that you can do is to start by drawing a little picture. All right. So let's say there's flat ground. There's a tree. Beautiful little tree. And then you walk 30 feet away from the tree. Let's say this is what you look like. Your hair was inspired by the tree, all right? And then what you know is that you walked 30 feet away from the base of the tree, and that the angle of elevation between where you were and the top of the tree was 57 degrees. And you're curious, this is a right angle, you're curious how tall. How tall that tree is. All right. So what do we have? Let's boil this triangle down. All we have is a triangle right here with 57 degrees, 30 feet, and X feet. So we just got to solve using trig. So how can we relate this angle with its adjacent side and its opposite side We need to find a trig function that relates an opposite side with an adjacent side. There it is right there. Good old tangent. Tangent never lets us down. TOA. SOHCAHTOA. All right. So that's what we're going to write down. The tangent of 57 degrees is the opposite over the adjacent. Solve for x. Multiply both sides by 30. You're going to get x is 30 times the tangent of 57 degrees. And you're going to type that into a calculator to get an approximation. 30 times the tangent of 57 degrees. We could use my favorite calculator, Google. Wait, whoa, this is very close. Kind of spooky, right? It was already written down. 30 times the tangent of 57 degrees. Make sure your calculator is in degrees, or if you're using Google, type in DEG. 46.20 approximately. Feet. Is about how high that tree is. Alrighty then. 57 degrees is coincidentally very close to a radian. But that's completely unrelated to this. But it's kind of a weird coincidence to see the 57 right there. But yeah, there we go. That's how tall the tree is. The end. Draw a picture, make a triangle, solve the triangle, profit. Let me know if you have questions, and good luck on the homework.